Works. All righty, folks. I believe we are live. Hey, y'all, it's Dr. Know-It-All. Guess who I got? I got Scott Walter. And without further ado, let's go to the star of the show here. You know, this is real hot take here, people. So thank you, Scott, for noting this for me. So we see here Optimus folding a shirt, and you might be like, whatever, no big deal, but this is a really, really big deal. So first of all, let us all, you know, take part in the joy of the fact that Optimus is folding a shirt, and perhaps someday we won't have to do that anymore. That would be really nice. So, but Scott, why is this a big deal? This apparently is 1x, right? We think it's 1x speed.
It looks to be 1x because, as someone pointed out, people in the background seem to be moving at normal speed.
Right.
So you can kind of use that to gauge it. And I'm pretty sure if it was like sped up or something like that, we would have seen something. Certainly everyone else would be there. Now, this is like a hot take on which we're like very immediate reactions and barely having time to really look at it very, very closely.
Exactly.
And someone else did notice, if you look at the lower right corner, occasionally you will see some hand motion going over there, which probably indicates that there may be some teleoperation involved in this. So this is the training. And we've seen that in the job descriptions of needing to have a teleoperator to be able to do this.
Correct.
So this is very similar to what the 3 grad students at Stanford were doing in the Aloha project of doing that. And Elon even confirmed in there that it's not fully autonomous yet, but it should be soon. Okay.
Right.
So yes, the knee-jerk reaction is like, holy crap, look at this. But you know, it's like not quite fully autonomous there, but it's getting close. Now, what they've basically done is proven a point that I think we made about a week ago when we saw the Aloha project. That one there showed that a really crappy mechanical arm with really crappy hands and with like probably almost no feedback whatsoever is dexterous enough to do something like, you know, I don't know if they showed folding a laundry, but, you know, making a bed and putting in a pillowcase and doing all sorts of other things that are still within the realm of being able to do this. And what that proved is kind of a point we were trying to make is like, well, how important is the brain and how important is vision and how much sensory data do you need? So at first we argued that you don't need to have sensors in Optimus between the cameras and probably the force feedback. And I suspect the teleoperator, even though it's not mechanically linked, maybe getting some haptic feedback from the system. Now, all telerobots used to do that because they used to be cable controlled. And so when you tried to close a gripper and you came down on an object, and of course a hard object, you couldn't close the gripper anymore because the cables prevented you. And so that was the sense of feedback that you got as a teleoperator along with your eyes. So just based on that and, you know, and vision and a really good neural network, which in these cases turns out to be a human brain, you can accomplish this. And we knew that with Optimus, you should be able to do it because it's much more like a human arm with much better hands and everything else at being able to do something that seems as dexterous as folding laundry. All that is confirmed is what we had expected. What we are seeing here is that Tesla is now going to be dropping these things probably more frequently than before.
Yes.
They don't want to be constantly upstaged by everyone else and say, we're going to wait for the next earnings call or something like that. It's like, nope, when we've got something to show, we will show that. So that's the first thing that we are really seeing there is that it has a capability and they are working on this to see how good it's going to. Now, why are they working on folding shirts and not something else that would be more related to the factory? And you could jump to a lot of conclusions. One is like, no, they're really focusing on this going into our homes next year. I don't think it's the case. They're just trying to kind of teaching a bunch of different tasks because, you know, folding a shirt like this is also akin to, I think, what you sort of said, you know, the fluffer bot. You know, one of these difficult kind of things where you've got something very flexible that's hard to handle and you want to work it out. So they're getting the training sets for things like that right now. Other takeaways in there. Now, when I first looked at this, I made the mistake of not like doing a screen capture and blowing it up. But we're all having a hard time counting the number of bots. At first, I said, "Oh, I think I see 4 bots in there." And someone else pointed out, "Wait a minute, there's a couple others," and it looks like there could be 6 or more. And it's a combination of Gen 1 and Gen 2. So a couple of cases, Gen 1 is pretty clear. The Gen 2s, I'm not sure if they're Gen 2s or Gen 1s that are kind of in a state of disrepair and being worked on. So I'm not sure what conclusions we can actually jump to right now as far as the number of Gen 2s. If that was now what we are seeing is several tables there, and you can imagine there's probably other rows of tables in a lot of other places, which is closer to the scenario I was imagining of like you're going to have this room full of all these bots doing all sorts of different tasks, training, and you're going to have lots of these.
Yeah. Okay. Wait. I got to break in. I just suddenly had this vision of an Optimus sweatshop. This is looking a little bit like one of those places that you see.
And I'm just waiting for the raid. I'm waiting for them to kick down the doors and come on in and say, all right, what's going on here?
Right. There's also this weird thing. Can you see my mouse moving? But this yellow thing down here that looks like it's in a few different places I swear, like nothing more than a Connect 4. You know, those like old games where you drop the little disc into the, I don't know what that is.
Could be. Now we are seeing, we are seeing something off the side, and I don't know what that, because my feeling is there's many ways you could be training Optimus. Right. And certainly we did see that there was the operator with the headset, and I think some kind of data gloves or something like that. But it wasn't really clear how they did the arm motion. There's no reason why you couldn't use something like Connect to track the movement of a human arm.
Right.
Translate that movement that you're seeing in the human arm into the kinematic model of Optimus, and then kind of put that back on over. And then of course the operator is looking at what's going on and trying in real time to correct it, to make sure the hand is where it expects the hand to be. Because again, there's that feedback between what would be your kind of kinematic sense, your proprioception, versus what you end up seeing. So the idea that if I close my eyes, I should be able to touch my nose and I'll come pretty close, but I might miss every now and then. I'm intentionally missing because I've done this so many times and so well practiced. I'm not quite at the tip of my nose, but if I open my eyes, I'm going to hit the tip of my nose every time because I'm able to mid-course correct. So the teleoperator seems to be close enough, but it's a little interesting. If the teleoperator is really off to the side, that would be almost a little bit harder to kind of be able to take a look at.
I imagine he's got some VR glasses on, so he's seeing through Optimus. I would have to.
He must be. He'd have to be doing that, exactly, because what Aloha was doing is they were standing right behind, so they almost actually had the robots. And of course, they didn't have the robot body in the way in Aloha. The head wasn't there to block your view, so when they were behind it, they were able to get a much better point of view of what's going on. So you're right; they would have to probably have something on there to be able to at least see what Optimus sees.
Yeah. And of course, I mean, the really big thing here, obviously, the step from doing this with teleoperation to autonomy is probably not as large as people might think, because, and thank you for Elon for clarifying that, but because of the neural network aspect and the ability for the robot to learn, there are versions of robots that are, you can teleoperate a dumb robot and it will do whatever you want, but this is clearly a step towards it doing it autonomously. But the really big deal here right now is that the teleoperator is essentially able to use his hands or her hands or whoever it is to virtually pick things up, and the robot is dexterous enough that it is matching those movements.
Yes. And the other thing to point out is I know the approximate height of the teleoperator. That teleoperator is somewhere between 5'7" and 5'11".
Okay, because the arms are the right length.
Said so. No, because it said so in the job description.
Oh, really?
Optimus is 5'9". Okay.
Yeah.
So unfortunately I cannot apply for the position. I'm too tall.
I can do it. I volunteer.
Complained he can't do it because he's not tall enough. But you can, and I think actually you're right in the sweet spot because
I am. I'm 5'10", so I'm very, very close to the same height as Optimus. So,
okay. Yeah. So very close. So it's like plus or minus 2 inches, and that's probably just to get some of the kinematics close enough. So so it doesn't have to be exactly the same. And of course, two people who are 5'9" are not going to have the same arm length.
A lot of it depends on your ape index.
Oh yeah, there's going to be all these other things. So they're able to take that and use enough math on that to be able to map it close enough to what they need. But once you go beyond that, it probably starts to like, it's not quite going to work. So unfortunately, that's part of the job description. For that to be a teleoperator, is you have to be within that range of heights.
Yeah. It feels a little bit like the early days of the space program. You know, the Mercury astronauts had to be max 5'10", or else they wouldn't fit inside the capsule.
Yes, exactly. Yeah, exactly. You had to be below. Yeah, exactly. And I don't even think any of them were 5'10". I think the highest might have been like 5'9".
Yeah, Gus Grissom was like 5'2" or something. So he was quite the short guy.
He was. Yeah. Yes, exactly. And if you've ever seen the Mercury capsule at the Smithsonian, you can see why.
Wear it. You wear it. You wear the capsule.
You wear it.
So, yes. So let's take a moment and just like
with a spacesuit and a helmet on at the same time.
That's right, because it's not just your height. Like I can barely fit inside when I go inside the model, but I forgot about the fact that you have a helmet on too. So that's, another inch or two that's on top of your head. So I'd be banging right up against the door. So anyway, important note, Optimus cannot yet do this autonomously, Elon saying that, but certainly will be able to do this fully autonomously and in an arbitrary environment, won't require a fixed table with box that has only one shirt. So clearly there are restrictions. Maybe it's not restrictions because it's teleoperated, but currently we have a fixed box on a fixed table. By the way, very standard. I've seen so many of these tables around the world. It's like the standard, adjustable height table. Yeah, but obviously it's in a somewhat controlled environment right now. But the goal is that we'll be able to do this it'll pick one shirt out of a group of shirts and be able to fold this thing. So
should be easy. The idea of picking a shirt out of a basket that's all clumped up and stuff like that will be very easy. And the idea of it telling it to pick a different colored shirt. Now, I kind of joked that it's probably only going to work for black T-shirts because that's like the only training set they have at Tesla.
By the way, I have the white shirt here.
Yes,
there we go.
One of the rare ones.
Had to wear my Robot Love shirt, so there we go.
Yeah. Unfortunately, mine's in the laundry. How ironic.
Did you bring it with you to Europe? Okay.
Yeah, I did, but it's in the laundry right now. I probably could have taken it out and no one would have noticed, but
we can't smell across the internet, so it's okay.
Yeah, exactly.
Yeah. But certainly we've got a really impressive demonstration going on here. And again, this is moving it's not as fast as a human can do this, obviously, but it is doing this at a reasonable pace. And this is very complex. This is much more complex than picking up a piece of machinery or bolts or a box of bolts or something and moving it to another place. And it just shows off the impressive work that they're doing here. So are we going to, I think we can more than double down on the fact that we're going to have Optimus in the factory doing useful work this year. In fact, it might already be doing that at this point. So
it could be. Now I did see, several comments out there. Someone said they would rather see it putting a nut on a bolt.
Right.
And it's like, but if I remember, Sandy says he saw something like that.
Interesting.
So, okay. Infamous video. So he didn't mention it in that one, but I think he mentioned it in his interview with Silicon Valley owners. And in that, he talked about, being able to see the bolt coming in there and threading it on there. So that might have been one of the scenes in that 3 to 5 minute video that he saw that no one else has seen, evidently, that he talked about in the Monroe video from the other day. So it seems like it's probably already doing other tasks like that. And now, this is a much harder one. You could imagine, well, if you're going on to T-shirts, you would then be able to move on to flexible cabling and a lot of other more, flexible type, or let's say things that are not always in the same position. That is going to require you to be able to adjust. And we know from the Aloha project, using whatever compute they had access to and whatever model they had, that just 50 trials was enough to teach these various tasks. So we may be seeing the same thing here. Let's not be surprised if next week or the week after we end up seeing something. Now,
let's see if I can find this. Sorry, I'm looking for. Here we go.
The fourth quarter, is it the fourth quarter, or is it going to be the actually 2023 results? That should be coming up, I think, next week, right? Isn't that we're pretty close to that.
Yes, it is. Yeah. Yeah.
Now, that's just a call. It's nothing else. So questions will come up, but they won't have anything. But
Right.
I would not be surprised to see another video get dropped somewhere around that time.
Right. Well, and let's not forget that Elon said specifically after the next earnings call. So he did one on SpaceX. And by the way, David Carbut, who is doing a lot of work for Farzad, is also editing for me now. So if people have seen like an improvement, including the thumbnail for this video, he was like, "I'll do it in 5 minutes for you." And I was like, "Cool." So anyway, so thank you, David. Big shout out to him. You can follow him on X. I'll put a link in the description after the live stream because I can't do it right now. But anyway, but yeah, he's doing amazing work. But yeah, but we are going to have some sort of thing that's similar to the SpaceX presentation about Tesla after the earnings call. So I expect probably more videos, or at least more of a description of what Optimus is doing at that point. So yeah.
Yes, I would think so. And there should be some questions on the earnings call. I hope Pierre gets one of the questions, because he seems to be the only one that actually asked a decent question. And I would not be surprised if he didn't ask something regarding this, because that is going to be one of the, let's say, the big things for going forward on understanding your valuation model. Where is Optimus? How soon before it's going to have an impact on margins by being able to do lots and lots of tasks? Now, earlier today, it was actually prompted by Jeff Lutz. He was talking something about how the training, or how the charging of the bots is going to happen, whether you'd have inductive charging and everything else. And we know that's been kind of a topic that's been going around, but today it seemed to take on a life of its own, with a lot of input about that. And I finally decided, it's like, okay, I know my gut feeling is you don't want a swappable battery pack from the standpoint of an engineer. The engineering that's involved makes it more complex. You add more mass, which means you're going to lose a little bit of performance. You add all these other things. And just listening to them, they talked about not wanting to have unnecessary things out at the extremities, which is you would need for a charging pad. And if you have a swappable battery pack, suddenly your battery pack can't be structural. And it sounded like they want the torso to be a little bit structural with the battery packs. So they want in there. So again, this complicates it from the standpoint of an engineering. And that was my gut feeling. Less parts, everything else, you don't want to do it. And that the bot is the swappable battery pack. When a bot runs out of juice, a fresh one just comes in and replaces it, and you go ahead and do that. So that's the practical way of being able to do it without doing excess engineering. But I talked to CERN about it, and he ran a model. And let's say he wasn't looking for any particular outcome. No matter how I try to guide him on it. And he was like that, it might actually make sense, going on in the future, to have swappable battery packs from the economic standpoint, because you would lose productivity from that one bot that's just kind of swapping around or something like that. So it may be possible, but I think in different settings, it's going to vary. So if you're talking about a factory that's 24/7 and you don't have any downtime, then you want the bots to just be up and running the whole time. You don't necessarily want a spare one, or one that's always off, basically losing, 1 out of every 10 bots is always offline. So you would like to be able to keep them up. But if you're not in a 24/7 kind of environment, or let's say you're first kind of bringing them online, your whole production line is still throttled by the way it's running right now, with other humans in there, with breaks, every couple of hours, and a longer break for lunch and stuff like that. So you might be able to get by with it at first without it. And again, what's important right now from the engineering standpoint is getting the bot to do stuff like this, like fold the laundry, not wasting energy on a swappable battery pack. Because that's one of those refinements and things you can improve. And as you go ahead, you might be able to see, do you really need it? How's economics dictate this? I don't think you need a swappable battery pack in the home. So if you're really thinking about Optimus coming to your house, it doesn't really have to be doing work 24/7.
And also, let's not forget that there are safety issues with swappable battery packs, because it's high voltage packs. You don't want consumers touching anything at high voltage with lots of
right. And there's other issues that you have to take into account, is that the bot can't necessarily swap its battery pack, because it's still going to need power. So it might have to somehow plug itself in, so it has the power to actually unplug its source of energy.
I also like, in a factory, you just run a cable to it, unless it's doing something highly mobile. in which case it needs to be able to move a lot. But if it's standing and folding laundry, I mean, whatever the job is, you know, if it's stamping a part over and over again, why can't you just plug it in and just have it be running off
right?
power?
Yeah. And I think you can have it easily tethered, and it doesn't have to be a very long tether that could provide enough.
And just as a note, I'm sure people have noticed this, but the robot itself is quite tethered in this situation. So probably one, just to keep it from falling over, just because, you know, it's expensive. But two, it's probably got data cabling for the teleoperator and for returning data to people so they can examine what's going on. And then three, I'm sure there's power coming into it too, so it doesn't have to run on batteries while it's doing something like
this.
So,
yes, it could be so that it's able to keep running if battery life is an issue at this point, and that we don't know. So there's going to be all sorts of different ways to be able to keep the bot running, you know, everywhere from induction pads, but there's also other forms of charging that are not necessarily inductive, that uses electric field instead, that does not require quite the same precision. And so if they're going to something else, they may be able to do something where the charging pads are not actually in the feet, but might be able to be closer to the torso. And that would be a better result, because then again, you're not adding anything to, any excess weights, you know, out at the feet or anything like that, because it looks to me like they took a lot of effort in reducing the mass of the bot. And I think a lot of the mass they tried to reduce was in the legs.
Yes.
That's the most important thing, is to reduce the moments of inertia of the legs to make the walking gait faster. So,
and if anybody has ever done backpacking or climbing or anything, they always say, what is it? 1 pound on the foot is like 3 pounds on your body, or, you know, you'd rather put more weight. You don't want to wear heavy shoes when you're walking, because the heavy shoes, every time you take a step, that's more effort, you know. So
yes, exactly. And, you know, they've seen that for a lot of people who are long distance runners, that it turns out that they're just like the calf muscles and everything, the weight on the lower extremities is lower than normal people, which is why they're able to run long distances and marathons better than else. So from an energy standpoint, there are biomechanically, there's a lot of reasons why you want to make sure the weight distribution down your legs gets less and less as you get out towards the feet, because that's where you're swinging a lot of the energy, and then put a lot of that mass more up in the torso, you will be fine. So so yeah, that's what I'd feel, is like if I could take a pound out of the legs but still have to then put that pound in the torso, I'm like, fine. If I'm just moving it from one place to another, I'll take that trade-off any day.
Yeah, and again, I mean, it's just obvious physics, because you think about it, your torso, if you're running or something, your torso is basically just kind of following a sine, you know, a sine wave, or a humping. Anyway, it's not doing any kind of flailing motion or anything like that, and that's where most of the energy is being expended. So okay, so do you want to take a quick look at some comments that folks have had? I see that there are.
I'm sure there's a lot. They've probably seen things that we completely missed.
Yeah,
because again, I've been looking at this on the small screen.
I can't promise that I'll get to everybody. So hi to the UK, laundry and vacuuming. Vacuuming would be cool. I would love to see you know, Optimus autonomously vacuuming, because as opposed to the iRobot, you know, non-automated vacuum.
You mean the Roomba?
It would actually, the Roomba. It would actually have to be able to visualize, understand, you know, what is a carpet? Is that a dog toy that's sitting on the floor, or a wire or cable or something like that to your lamp? So that would actually be quite the good demo. You know, you might think like, oh, no big deal, but a Rosie the Robot demo of it folding laundry autonomously and doing vacuuming, even if it was not going to be used for the household for right now, would be an excellent demonstration.
Well, doing things like stairs, which you cannot do with the autonomous vacuum cleaners.
Correct.
Being able to vacuum any corner properly, because you don't have a round shaped thing trying to go in there, so it's able to get, you know, kind of the proper suction in those areas. Being able to lift things out of the way. So like around the dining room table, the kitchen table, you need to pull the chairs out of the way to be able to vacuum it in there, and then push them back. The idea that you can just operate around those things, that doesn't really work. You know, you constantly have to move things and put them back into place, as well as pick up the clutter, pick up the dirty laundry that's on the floor, the socks and stuff like that, anything else. So there's a lot more to vacuuming than just running the vacuum cleaner.
And if you have like a Dyson that's a battery operated thing, it's one thing, but also you have to deal with cable management. If it's an electric vacuum, you know, you have to plug it in. You have to. There's always that little dance of like pulling the cable with one hand and vacuuming, and you know, so it's not running over its own cable the whole time. So it's quite you know, it's quite a task to vacuum. So, you know, folding the household things, people might be like, why are they demoing something household if they're not selling it to the household? They're doing it because these are very, very complicated tasks and they have an uncontrolled environment to some extent. Because, like you said, there could be socks on the floor, you know, kids' toys, you know, cords, things like that. All sorts of random things just show up. And of course, I was at CES, and FYI, the haptics thing. I actually have a video coming out about a small company that's working on a haptics glove that's very cool. It's got cables across the back end of it and everything. So, you know, you could see the operator having something like that. So when it gets to the shirt, he can feel it, like actually feel it, like picking it up. So anyway,
exactly. And you need the haptics for that. Again, you don't want to have a controller where you can just say, oh, I'm going to move my hand all the way down like that, and the hand stops around here. You want to have that feedback that lets you know, oh, I'm feeling resistance right here, and it's really hard resistance. And your controller, I'm not going to allow you to move it down anymore. That's a little bit of that feedback that you would want to have. And the interesting thing is that, you know, the egg demo that we saw with Optimus is it was using the fingertips in there to be able to kind of feel something about the object. But I still think, I'm not sure that that feedback is enough, because you could, if you pick up an egg and you felt the egg, would that somehow tell you that, oh, be careful, this is going to break, it's fragile? An egg doesn't feel fragile to you. We know the egg is fragile because we've learned how easy they are to break, because we see it, we associate it with it. That's fragile, be easy with it. So I always felt Optimus should be able to pick up an egg without having a sense of touch, because it should know from its database, just from vision, ooh, be careful, that's not a baseball you're picking up. So you have to grip it very differently, very, very differently. It's something else if you're picking up something softer, you need to feel the surface. Now, it may be that you get enough from the touch sensing that you feel something about the surface that says, oh, even though I don't see this thing, it feels like an egg versus it feels like a baseball. So I know I'm going to have to be kind of dainty with it. Or it feels like a Nerf ball, and then you get that kind of sense. But that will also be the haptic feedback, the force feedback that you would normally get from a baseball or something else. That, oh, I was able to close my fingers really easily, and suddenly, instantly, I'm feeling a lot of resistance. Versus a Nerf, it's like, oh, I'm feeling a little bit, but the more and more I press, I get a little bit more. So it seems to be a soft, squishy thing as opposed to something that's very hard.
So yeah, so and even with the egg, I can see it's helpful, because if you're picking it up and it's kind of damp or something, like let's say you just washed it and you pick it up, you're going to have to add a little more force to it to, you know, to make sure it's not, doesn't start slipping. So I could see the benefit, although for the egg, less so than the visual of just seeing the fact that it's an egg and knowing that you have to be careful with
it. It'll be interesting to see how much the sensors on the end of the fingertips help in this demonstration, or whether it's even needed at all. Because again, my contention always was, I don't even think you need it for doing the laundry. I just wasn't sure if it was ready for it. So I'm kind of getting ready to, you know, eat the humble pie here and saying that, oh, it was able to do everything. It can do laundry, it can sort all the stuff and make piles. I'm just not sure, you know, whether right away it will be able to fold the laundry. So this is like the one time I'm really glad I was wrong.
Yeah, exactly. It's great. And again, just for people who are tuning in late, Elon has been very specific. He notes that it is not fully autonomous. It's being run by a teleoperator who we think we're seeing their hand kind of like showing up in the edge of the screen once in a while.
Right up on the right. Yes. Right up on the right. Yes.
And it looks like they are wearing some sort of haptic glove. It's black. So, but anyway, but this is something that, you know, the neural networks will learn from these demos to be able to do it itself. So, let's see what can't wait for. So let's see the T for bonkers soft fabric. Peter Lewis notes that, you know, it's soft fabric is a really hard task for a robot. It's hard for us humans. It's not something you can give a 2-year-old. They're not, you know, they've had 2 full years on the planet to learn how to do things, and they can't fold laundry. It takes a while to figure out how to. They also have no motivation to fold laundry, but but anyway, it takes a while to learn how to do that. Look at
the teleoperated is also pretty hard. You know, it's like, it takes a long time to get these. So I think probably the other thing you'd want to have in the job description, besides being between 5'7" and 5'11", is really good game player. You know, it's like you need to be skilled at playing video games, because you're really used to these different controllers and kind of having a different sense of presence of where you are. It's for someone who's never played a video game, it would be really hard. No doubt about it.
Well, and even more than that, specifically if you played like Oculus type, you know, VR games, you're going to be even in better shape for that.
Mm-hmm.
And someone did notice, who was that? P. Gabrick 235. The Optimus that's to the sort of right of this Optimus, you can see it like swinging. It looks like it's hanging. I mean, it is hanging. It's just funny. It's just like kind of swinging there in the background.
Yes, they're much. It's probably being worked on. So we are seeing the lab. So we're not sure how many of them are functioning in there and how many of them look like they're being assembled. And again, there are some Gen 1s back there as well.
Yeah,
and
there's one from Gestalt here.
Gen 1 or Gen 2. Mm-hmm.
Yeah, there's a question from Gestalt about whether this little weird white and blue pack here is the battery pack. I don't know what that is. I see definitely a stop button there. It looks like that yellow box with the red button is a stop button that they could,
Oh, underneath. Underneath.
Yeah. Sorry, are you not seeing my mouse? Can you not see that moving or not?
I'm looking at a really small screen.
Oh, okay. Well, anyway, the mouse
on my
right there.
phone right now.
Yeah.
So I see something underneath the table that has nothing on top of it. There seems to be a box underneath it. And
no, it's over the bottom, just past his left hip. Down angle from the left hip. There's a yellow box with a red button, which is an obvious stop button. It's like a kill
okay.
It. But then right above that, there's a sort of rectangular. Honestly, it looks kind of like a Tesla power wall. Not power wall. Sorry, the thing you hang on the wall to like charge your car. It looks a little like that. So it could be a voltage converter or something. Yeah, so that is possible. Yeah, that might be something like that. Teleoperated, yes, I see 8 bots. Model World, thank you for counting, Model World. Yes, and there is a hand at the right. That is definitely the teleop. Well, we don't know for sure, but it's likely the teleoperator. Peter Lewis says something about holds the batteries, but I don't know exactly what that. Maybe that is the white thing back there, but I thought he had a battery sort of pack integrated into his body at this point.
Yeah, I think the batteries should be integrated in the body, so I'm not sure what the other batteries would be for. Right. Because if he's tethered and needs additional power, I think it would be coming from that. But the full battery pack should be integrated into the torso.
Right. Mark Jones here actually said something. It catches the shirt with its left hand as the shirt moves due to physics. So let's take a look at that. So I don't know exactly at what point, because obviously I've been talking, so I haven't been paying quite as close of attention. But that is interesting. If it does that, I don't know if that would be the teleoperator noticing it and moving it itself, or so I don't know if it's maybe at the end or at the beginning here. So we'll have to watch back through again and see where that motion is.
Now, actually, what would be interesting is if you've ever gone into a clothing store.
Yes.
The attendants that are, especially, where you go over and look at the T-shirts or anything else, there are a lot of people just come on, they take it out, and they kind of look at it, and then they just throw it down. And they come over, and they have a specific folding process. In some cases, they do have something to make it a lot easier, a little form that they can put on. But others, they just know, and there's a certain way you're supposed to fold it that looks better on display.
Yes.
They should bring in one of those consultants to show this is the proper way to fold a T-shirt.
Well, actually, my wife, except she's too short, she used to work at JCPenney while she was in college. And so she actually loves folding shirts. Don't ask me why, but she does. And so I was like, she would be the perfect person, because she could be like, oh, I know exactly how to fold this thing, and I can do it 100 times, as demos.
Yes, so. much faster, because there is actually a technique. So again, it was like, we were kind of surprised that 3 grad students actually knew enough about cooking to be able to show a robot how to cook.
Right.
I guess we should not be surprised that a bunch of engineers would actually know anything about doing the laundry, let alone folding a T-shirt, So maybe they really should go to a clothing store and get a couple of the people that work there and say, okay, what's the trick? What's the technique? And let's go ahead and show that to Optimus, because we don't want Optimus to fold shirts the way the rest of us do. We want it to do it like the pros.
Right.
And unfortunately, none of us have really learned the proper way to fold a T-shirt.
Yes.
And there are people who figured it out because they're in the business of this.
Right.
And they have to fold them all the time, and they have to fold them quickly.
I want to break in because this is number 1. Thank you, Tino from Jamaica, for the super chat. Thank you so much for that. But he also notes that teleoperation can be used as remote workers for people in developing countries, using VR glasses, gloves, and glasses. So this is not just a training thing. Robert S. also said this is a training procedure. Yes, it definitely is, because what you're seeing is the robot can learn because it gets to do a repetition over and over again. But beyond that, even if you sort of take away the fact that the robot could eventually learn to do this autonomously, doctors, if a doctor needs to come and do something like, maybe a doctor's a little bit much at this point because that requires a lot of skill surgery wise, but you can think about the robot being a substitute human in difficult places to reach, not just developing countries, but if there's a disaster or something, it can go in and potentially dig through rubble, which is very, very dangerous when after an earthquake or something, when there's all these collapsed situations. So there are situations where it doesn't even have to run autonomously. It could run with a teleoperator and be incredibly effective for some jobs. So yes, very, very good point.
Right. But you can also think of the other way around. Someone in Jamaica could be teleoperating this right now and doing the training data.
Yes.
So if you needed to have a lot of teleoperators, they do not necessarily have to live in Palo Alto where the cost of living is super high.
That's true.
So it's quite possible that, you could do it remotely. So I think that might have been the point he was getting to. Is like, I don't need a visa to come to the US to do this, do I? I could just teleoperate it.
Yeah. That's true. And honestly, with Starlink now, they've got the kind of, with SpaceX, they've got the whole solution. So yes, Tina, you should actually, if you're between 5'7" and 5'11", you should apply for the job and see if they'll do it remotely. That'd be pretty cool.
Yes, and do it with Starlink because the latency might be there.
Yeah. So Gestalt says, yes, I think they're collecting training data from different tasks. So yes, the likelihood here is that we're getting training data that is being done this way. The other direction, and oh gosh, I've seen so many robot videos recently. I know that Figure talked about it watches TV and essentially learned how to do the coffee cup thing by just watching videos. But oops, Scott may have frozen on me there. But anyway, I don't know if they've talked about that with Tesla yet, with Optimus, whether it can learn from watching videos themselves. But I mean, this is certainly an effective way of doing training, but also even more effective would be if you can just like sit it down virtually in front of a TV, and just like feed it a bunch of video images, and it can learn that way as well. So there's a multimodality of learning potential. So yeah.
Right. And we're hoping that's what it comes down to, is that at first you're going to have to train it with whatever methods sort of work to get the net up to a certain level of sophistication.
Right.
Then at that point, it should be able to see new tasks and kind of realize that, this is just a combination of all these skills I already have. And I'm able to kind of
classic transference learning. Yeah. Something like that.
Yes. So you do something like that. And then you also want to add a little bit of curiosity in there. So when the robot comes into my home, I want it to realize like, you have a kitchen, just like everyone else has a kitchen. However, your kitchen is laid out differently than everyone else's. So I'm going to explore your kitchen for a little bit to find out where you prefer to put your coffee cups, how you prefer to hang them, where the silverware drawer is, what you have, how it's all there, and get kind of familiarized with it. And that is going to require a certain sense of curiosity to want to explore the environment, to know how it works, to realize that, also, your fridge opens to the left and not to the right, and all those things, to know that, as opposed to how it may have been trained.
Right. And let's not forget that, the important thing about learning is making mistakes. You learn, like, if you were born knowing all of Einstein's general relativity, you have to learn, you have to fail along the way to figure out how to do all the math up to something like that. So some creativity, some inquisitiveness, and also the ability both in the robot to fail and to learn from failure, to go like, oops, I dropped that, okay, so let me figure out how I can do it better next time and not drop it. So, that kind of a thing is very important. Theodore here has a good thing. Oops, sorry. So Theodore has a thing which says, a question which says, do we want Optimus doing such a task? I think not. This is for demonstration purposes only. We both agree with that. We want Optimus to do things that are too dangerous for humans. So I think Elon has even noted that the 3Ds, dull, dirty, and dangerous. It's like, those are the jobs first. Or if not Elon, it was definitely
that was more Sandy. That was Sandy. Sandy was the 3Ds.
Right. Yeah.
Elon has been boring, tedious, and dangerous, I think.
Yeah.
So folding,
same basic idea.
is boring and tedious. So that certainly fits the bill. It may not be dangerous, but definitely it fits the boring and tedious. And so that's what they're looking at. And because it's been brought out time and time again that there are a lot of job shortages, because there are jobs that just people do not really want to have except for a very short period of time.
Yes.
And then you do it, and then it becomes very boring, and they quit, and then you have to find someone else. So the turnover that a lot of these companies are having is just too much. And the only way they can actually, and there's nothing, it's not like they do whatever they can to make the job attractive, but still it's not enough. They can raise the pay, they can do everything else, but still people don't want to do it. So they are being forced to automate in many cases for that reason, because of turnover. And, this is like one example. It's like, who wants to fold t-shirts day in and day out? There's a small number of people that would like to do that.
Let's put this in, let's shift this to a commercial situation, which I think people will probably be able to relate to. If you've done this as a job or are doing this as a job or not, you've seen people do it. And that is like a French fry operator in the back of a McDonald's or something, right? That is not just boring and tedious and doesn't pay that well, but it's also quite dangerous. You are around stuff that will literally kill you if you spill it on you, enough of it. So
it happens every now and then, so it gets spilled and people get third-degree burns from that all the time. And they do whatever they can to try to prevent that, because the last thing the owners want is for something like this to happen. But despite that, and despite all the worker training, these accidents will happen.
Yeah. And so, and also it's just hot and miserable standing next to a fryer thing for hours a day. Right. So this is a perfect example of a commercial situation. And again, much easier than folding clothes. I mean, it's like you reach down, you grab that handle, you pull out the fries, you shake it, you put some salt on it, get the new frozen fries, put them in, so it's a process that if it can fold clothes like this, it can certainly do something like that. No question.
Usually when the errors happen, it's like late in the day where you've been doing it, your mind is starting to wander, you're a bit tired, and then you make a simple mistake. Or you've been doing it so much, you just kind of get blasé and you forget how dangerous it is. And then a slip up happens like that. And usually every time it's that. And then of course the other thing is it's sometimes a combination of 3 or 4 things just happen to go wrong at the same time.
Right.
And then
that's
something.
I have a strong theory in accidents that 99% of them are caused by at least 2 causes. And you think about auto accidents. Yes, somebody may have cut you off or something, but also you looked over to the side to talk to your kid or looked at your phone. There's almost always 2 causes to an accident, not just one.
And usually when they look at like aircraft accidents, when that happens, it's like usually 3 or more things that just happen to go wrong. It's that kind of Peter principle thing that's, something, and they just happen to all go wrong at the same time that causes that. And then it was just like, it's not that it was poorly engineered. It's like, we just could not believe that these combination of events, confluence events, could possibly all happen at the same time. But that's what happens. That's the nature of reality when you have so many cars on the road and everything else, so many different combinations of things are happening that sooner or later, a couple of them are going to line up to be the one that causes some weird accident.
Right. Yeah, exactly. And so, anyway, but the good part about this is we're talking about being able to shift a robot into positions to do jobs like this, whether it's digging through rubble after an earthquake, or doing fry cook job, or even in laundromats, not laundromats, dry cleaners. It's pretty dangerous to be in there because of the chemicals and the heat and everything. It's not the greatest life because you're breathing in a lot of nasty chemicals. So that's another place where a robot that can fold laundry. So, for people who are like, oh, this is a household demo, they're never going to sell these. They probably are not going to sell them to you as a consumer for quite a while because, again, there's a lot more restrictions on selling to a consumer. And also there's just not the profit in it. The consumers care about cost. Factory things, if you're paying somebody $50,000 a year with salary and benefits, then paying $35,000 for a robot a year, it doesn't matter. So,
and CERN has done those models on what the value is of the Optimus bot. And it's north of $100,000. We're not saying that's how much it costs to build the thing, but people would be willing to pay up to $100,000 or more per year for an Optimus bot for use in the factory.
Right.
And
what I was thinking was substituting for one person, but you might go ahead.
When you look, for one person, it's a little bit less than that. But the thing is, it's substituting for more than that. So that's usually the value proposition of really how much it's worth. And so until you have enough bots that everyone that needs a bot in the factory has one in the factory, only then are you talking about the prices being able to come down. You can start buying it in home. So even if they can produce these for $10,000 a piece, which I believe they can, and they will be able to at some point, they will not sell them for that much because their value is so high. And that's the same thing you can say about a lot of software products that are out there. Is the software products, they can be mass produced for practically $0. We know that. It's just as simple as copying it. Yet they command a very high price. And why is that? It's because of the value to the end user on what it's able to do and what it's able to produce. So this is what you're seeing here is the bot will be very cheap for them and for them to use internally. But once it starts to go externally, the price has to match what its real value is. Otherwise, there's going to be a derivatives market in there of people just taking the bot. It's like, oh, great, I can get it for Tesla for 30,000. I'm going to turn it around and now sell it to someone else for 100,000.
Yeah.
So they have to make sure they actually meet what the true supply and demand level is, which at first is going to be very high, and then it will come down to be available in the house.
Yeah, yeah. I think Gestalt said something about the Swiss cheese model for why accidents happen. I don't know what the Swiss cheese model is, but I'll have to look that up. So
I've heard it, but I can't remember it. But yes. Yeah.
Anyway, so, okay, I have kept you for 45 minutes. Scott, if you don't know, I think we skipped that all at the beginning, but you are vacationing in Europe right now. And so I'm eating into your time. And plus it's probably like 9 o'clock at night there. So I don't want to keep you
too much. Well after 9. Yeah. So, be coming home in about a week or so. So,
okay.
Yeah, and then we'll have a more normal setting in the background.
Yes. We'll be back on our regular Starlink to Starlink. Yes. So yeah, we'll be a little more there. All right. So thank you so much. And thank you to everybody who's watching and all the questions. Sorry, we couldn't get to all of them. There are a lot of really good questions. So for folks who are watching later, read the comments and everything. So again, just recap really quickly. This is not fully autonomous at this point. This is teleoperated, but Optimus is showing off an incredible amount of dexterity and also vision and things like that, because we assume that the teleoperator is looking through the cameras in the robot and manipulating the hands of the robot directly. And so it's very, very impressive stuff. And as Elon notes in the comment down here, it will be able to do this fully autonomously in an arbitrary environment. And that's also very important because uncontrolled environments are important for this kind of thing too. So anyway, that's the recap. Thank you all for watching it. And yeah, we'll see you in the next one. We'll see you the next time Tesla drops another one of these things real quick. We'll have to jump on again. So ciao, everybody. Have a good day.
Okay, cheers.
Bye.